Right. Next one is that cloud computing and cloud application development. Cloud application developments. Okay, there are three services are available in the cloud computing. First one is the software as a service. Second one is the platform as a service, and third one is the infrastructure as a service. The infrastructure as a service is the beginning service. After that, they are using pass platform as a service. నెక్స్ట్ సాఫ్ట్వేర్ యాజ్ ఎ సర్వీస్ అనేది మనకి ఆల్రెడీ ఇది ఫస్ట్లో మనం చెప్పాం. ఓకే, కమింగ్ టు ద ఈసీ2 ఇన్స్టాన్సెస్ అండి. అమెజాన్ వెబ్ సర్వీసెస్లో ఈసీ2 ఇన్స్టాన్సెస్. ఓకే, సి హియర్ ఈసీ2 ఇన్స్టాన్సెస్. ఓకే, దిస్ ఇస్ ద డయాగ్రామ్ హియర్. అంటే అమెజాన్ వెబ్ సర్వీసెస్కి వెళ్ళిన తర్వాత ఇవన్నీ మనకు కనిపిస్తూ ఉంటాయండి. ఓకే, డైరెక్ట్ కనెక్ట్ ఈసీ2 అని, ఎలాస్టిక్ మ్యాప్ రెడ్యూస్, రౌట్, ఇట్లా ఒక సర్వీస్ని మనం ఏదో దాన్ని తీసుకుంటూ ఉంటాం అనమాట. రైట్, దట్ ఫిగర్ డిస్ప్లేస్ ద అమెజాన్ మేనేజ్మెంట్ కాన్సోల్ అంటాము. ఓకే, అంటే మనం ఏమి తీసుకోవాలనేది ఏఎంసి అమెజాన్ మేనేజ్మెంట్ కాన్సోల్ విండో. ఓకే, లిస్టింగ్ ద అమెజాన్ వెబ్ సర్వీసెస్ ఆఫర్డ్ ఎట్ ద టైమ్ ఆఫ్ దిస్ రైటింగ్. ఓకే, మనం ఈ టెక్స్ట్ బుక్ రాసే టైంకి ఆ సర్వీసెస్ ఉన్నాయి అక్కడ. The services are grouped into several categories: computing, networking, storage, and a content delivery, deployment and management, databases, application services. ఇవి చాలా సర్వీసెస్ ఉన్నాయి మనకి. కంప్యూటింగ్ సర్వీసు, నెట్వర్కింగ్ సర్వీసు, స్టోరేజ్ సర్వీసు, కంటెంట్ డెలివరీ సర్వీసు, డిప్లాయ్మెంట్ సర్వీసు, మేనేజ్మెంట్ సర్వీసు, databases and application services also is available in the Amazon management console. In spite of the wealth of information available from the provider of cloud services, the learning curve of an application developer is still relatively steep. The examples discussed in the chapter are designed to help overcome some of the hundreds faced when someone first attempt to use the AWS. Okay, due to space limitations, we have chosen cover only a few of the very large number of combinations of services, operating systems, programming environments supported by AWS, Amazon Web Services. Okay, see here. If you want to access AWS, so you need to go through this HTTP aws.amazon.com website. Once the account is created, the AMC allows the user to select one of the services. EC2 is the one of the services. Okay, Elastic Cloud Computing and EC2 and EC square లాగా CC అనమాట. C2 అంటే కావాలని ఎంత కావాలని అది సాగదీయచ్చు. ఎలాస్టిక్ అంటది కదా, అలా సర్వీసెస్ ఇంక్రీజ్ చేయొచ్చు, డిక్రీజ్ చేయొచ్చు. అది ఇక్కడ EC2 and then start an instance here. Okay, recall that an AWS EC2 instance is a virtual server started in a region and the availability zone is selected by the user. Instances are grouped into a few classes and each class has available to it a specific amount of resources such as CPU cycles, main memory, secondary storage, and communications and IO bandwidth. Several operating systems are supported by AWS, including Amazon Linux, Red Hat Linux, SUSE Linux, Enterprise Server, Ubuntu Server, and several versions of Microsoft Windows. ఇవన్నీ కూడా మనకి ఆపరేటింగ్ సిస్టమ్స్ సంబంధించినవండి. The next step is to create an AMI on one of the platforms supported by AWS and start an instance using the రన్ ఇన్స్టాన్స్ ఏపీఐ. రన్ ఇన్స్టాన్స్ ఏపీఐని యూజ్ చేసుకుని మనం ఈ ఇన్స్టాన్స్ని క్రియేట్ చేయొచ్చు ఏఎంఐ. ఇఫ్ ద అప్లికేషన్ నీడ్స్ మోర్ దాన్ 20 ఇన్స్టాన్సెస్, ఏ స్పెషల్ ఫామ్ మస్ట్ బి ఫిల్డ్ అవుట్. అంటే ఎక్కువ వాడితే కనుక ఒక ఫామ్ని ఫిల్ చేయాల్సి ఉంది. ద లోకల్ ఇన్స్టాన్సెస్ స్టోర్స్ persist only for the duration of an instance. The data will persist if an instance is started using the Amazon Elastic block storage, and then the instance can be restarted or at a later time. Once once an instance is created, the user can perform several actions. For example, connect to the instance, can launch more instances identical to the current one or create a EBS AMI. The user can also terminate, reboot, or stop the instances. The network and security panel allows the creation of security groups, elastic IP addresses, placement groups, load balancers, and key pairs. Whereas the EBS panel allows the specification of volumes and the creation of snapshots. Right, connecting clients to cloud instances through firewalls. Okay, how to connect to clients through firewalls అనేది చూద్దాం. A firewall is a software system based on a set of rules for filtering network traffic. Its function is to protect a computer in a local area network from unauthorized access. The first generation of firewalls, the first generation of the firewall, the first generation of the firewalls deployed in the late 1980s carried out packet filtering. ఫస్ట్ జనరేషన్ ఆఫ్ ఫైర్ వాళ్ళు ప్యాకెట్ ఫిల్టరింగ్ కోసం యూజ్ చేసేవాళ్ళు అండి. రైట్, దే discarded individual packets that did not match a set of acceptance rules. Such firewalls operated below the transport layer and discarded packets based on the information in the headers of physical data link and transport layer protocols. The second generation of firewalls operate at the transport layer and maintain the state of all connections passing through them. Unfortunately, this traffic filtering solution opened the possibility of denial of service attacks. A denial of service attack targets a widely used network service and forces the operating system of the host to fill the connection tables with illegitimate entries. DOS attacks prevent legitimate access to the services. The third generation of firewalls understand widely used the application layer protocols such as FTP, HTTP, Telnet, SSH, and DNS. అంటే డేటా ట్రాన్స్ఫర్ కోసం ఇది వాడతాం మనం. ఈ ఫైర్ వాల్స్ ఏమో సెక్యూరిటీ కోసం వాడతాం, ఆపరేటింగ్ సిస్టమ్ వర్కౌట్ చేయడం కోసం వాడతాం. రైట్, ఫైర్ వాల్స్ స్క్రీన్ ఇన్కమింగ్ ట్రాఫిక్ అండ్ sometimes filter outgoing traffic as well. A first filter encountered by the incoming traffic in a typical network is a firewall provided by the operating system of the router. The second filter is a firewall provided by the operating system running on the local computer only. Typically, the local area network of an organization is connected to the internet via router. A router firewall often hides the true address of host in the local network using the network address translation mechanisms. Right. The host behind a firewall are assigned address in a private address range, and the router uses the NAT tables to filter the incoming traffic and translate external IP addresses to private ones. If one tests a client server application with the client and the server is in the same LAN, the packets do not cross a router. Once a client from a different LAN attempts to use the services, the packets may be discarded by the router's firewall. The application may no longer work if the router is not properly configured. Now let's examine the firewall support in several operating systems. Okay, this table summarizes this one. Right. Here, a rule specifies a filtering option at one network layer when filtering is based on the destination address or IP address. అంటే మనకు ఒక రూల్ ఉంది, ఎక్కడ ఫిల్టర్ చేయాలి ఫైర్ వాల్ అంటే నెట్వర్క్ లేయర్లో చేస్తాం. దీనిని నెట్వర్క్ కనెక్షన్స్ నెట్వర్క్ లేయర్లో ఉంటాయి కదా, ఐపీ అడ్రస్ని బేస్ చేసుకొని డెస్టినేషన్ అడ్రస్. నెక్స్ట్ ద ట్రాన్స్పోర్ట్ లేయర్ వెన్ ఫిల్టరింగ్ ఈజ్ బేస్డ్ ఆన్ ద డెస్టినేషన్ ఆఫ్ ద సోర్స్ పోర్ట్ నెంబర్. అదేమో ఐపీ అడ్రస్ నెట్వర్క్ లేయర్లో, ట్రాన్స్పోర్ట్ లేయర్లను పోర్ట్ నెంబర్ యూజ్ చేస్తాం. థర్డ్ వన్ ఈజ్ ద మ్యాక్ లేయర్ వెన్ ఫిల్టరింగ్ ఈజ్ బేస్డ్ ఆన్ ద డెస్టినేషన్ ఆఫ్ ద సోర్స్ మ్యాక్ అడ్రస్. In Linux or Unix systems, the firewall can be configured only as a root using the sudo command. Okay, the firewall is controlled by the kernel data structure is IP tables. The IP tables command is used to set up, maintain, and inspect the tables of the IPv4 packet filter rules in the Linux kernel. Several tables may be defined. Each table contains a number of built-in chains and may also contain user-defined chains. A chain is a list of rules that can match a set of packets. The input rule controls all incoming connections. The forward rule controls all packets passing through this host, and the output rules controls all outgoing connections from the host. You see here, this is the client and this is the router. In client, we can use the antivirus, and there is a OS firewall is there, and a router firewall is also there. This is the network in between the source and destination systems. There is a network cloud is there, network is there. Okay, in clouds, in one more side is there, router firewall is there in at the router, and at the server also there is OS firewall is available. Okay, right. A rule specifies what to do with a packet that matches. Accept, let the packet pass, drop, discharge, and the packet queue, pass the packet to the user space, or return, stop traversing this chain and resume processing at the head of the next chain. Okay, right. To get the status of the firewall, specify the L action of the IP tables command sudo IP tables minus L. As a result of this command, the status of the input forward output chains will be displayed. To change the default behavior for the entire chain, specify the action P, that is policy, the chain name and the target name. Example, to allow all outgoing traffic to pass unfiltered, use sudo IP tables minus P output accept S. Right. To add a new security rule, specify the action A, the chain, the transport protocol TCP or UDP, and target ports. As in sudo IP tables minus A input minus B minus TCP minus D port SSH minus J accept it. Yet to delete a specific security rule from a chain, set the action D and specify the chain name and the rule number for that chain. The top rule in the chain has number 1 only. Sudo IP tables minus d input 1. Sudo IP tables minus d output 1. Sudo IP tables minus d forward 1. Okay. Right. By default, the Linux virtual machine on Amazon EC2 accept all incoming connections. Okay. The ability to access that viral the virtual machine will be permanently lost when a user accesses an EC2 virtual machine using SSH and then issues the following command sudo IP tables minus d input drop. The IP tables list అన్నమాట. The access into Windows 7 firewall is provided by a GUI access follows. Go to the control panel, select the system and security tab. From there, Windows firewall and advanced settings. అట్లా వెళ్ళాలి మనకి విండోస్ సెవెన్లో మీరు ఫైర్వాల్ని యాక్సెస్ చేయాలంటే కనుక రైట్ the default behavior for incoming and outgoing connections can be displayed and changed from the Windows firewall with advanced security on local computer. Access to Windows XP firewall is provided by a graphical user interface accessed by the selecting Windows firewall in the control panel. So if the status is on, incoming traffic is blocked by default and a list of exceptions defines the connections allowed. The user can only define exception for TCP on a given port, UDP on a given port, and a specific program Windows XP does not provide any control over outgoing connections. Right, antivirus software running on a local host may provide an additional line of defense. Okay, for example, the Avast antivirus software is there. Okay, several real-time shields are there. Okay, right. Security rules for application the transport layer protocol in EC2. A client must know the IP address of a virtual machine in the cloud to be able to connect to it. The domain name service is used to map human-friendly names of computer systems to IP address in the internet or in private networks. DNS is a hierarchical distributed database and plays a role reminiscent of a phone book of the internet. In late 2010, Amazon announces a DNS service called the Route 53 to route users to AWS services and to infrastructure outside of the AWS. A network of DNS servers is scattered across the globe, which enables customers to gain reliable access to AWS and place strict controls over who can manage their DNS system. who can manage their DNS system by allowing integration with AWS identity and access management. For several reasons, including security and the ability of the infrastructure to scale up, the IP addresses of instances visible to the outside world are mapped internally to private IP addresses. A virtual machine running under Amazon EC2 has several IP addresses are there. Okay, EC2 private IP address, EC2 public IP address, EC2 elastic IP address. Okay, there are three types of IP addresses are there here. First one is the EC2, EC2, yeah, EC2. EC2 private IP address. The internal address of an instance. It is only used for routing within the EC2 cloud only. The EC2 private IP address, it is internal address of an instance. It is only used for routing within the EC2 cloud. EC2 public IP address. A network traffic originating outside the AWS network must use either the public IP address or the elastic IP address of the instance. The public IP address is translated using network address translation to the private IP address when an instance is launched, and it is valid until the instance is terminated. A traffic to the public address is forwarded to the private IP address of the instance. Right. Next, EC2 elastic IP address. Okay, right. The IP address allocated to an AWS account and used by traffic originated outside AWS. A NAT is used to map an elastic IP address to the private IP address. You see there, there are three types of IP addresses. ఇక్కడ చూడండి ఒకసారి. Elastic IP addresses allow the cloud user to mask instances or availability zone failures by programmatically remapping public IP addresses to any instance associated with the user's account. This allows fast recovery after a system failure. For example, rather than waiting for a cloud maintenance team to reconfigure or replace the failing host or waiting for DNS to propagate the new IP to all of the customers of a web service hosted by EC2. The web service provider can remap the elastic IP address to a replacement instance. Amazon charges a fee of unallocated elastic IP addresses. Okay, right. Amazon Web Services use security groups to control access to users' virtual machines. A virtual machine instance belongs to one and only one security group, which can only be defined before the instance is launched. Once an instance is running, the security group the instance belongs to cannot be changed. However, more than one instance can belong to a single security group also. A security group rules control inbound traffic to the instance and have no effect on outbound traffic from the instance. The inbound traffic to an instance, either from outside the cloud or from other instances running on the cloud, is blocked unless a rule stating otherwise is added to the security group of the instances. For example, assume a client running on instance A, the security group sigma A is to connect to the a server on instance B, listening on TCP port P, where B is in security group sigma B. A new rule must be added to the security group sigma B to allow connections to port P. To accept responses from server B, a new rule must be added to security group sigma A. Okay, the following steps are there here. Okay, right. Sign in to the AWS Management Console using your email address and password and select EC2 service. Use the EC2 request instance wizard to specify the instance type, whether it should be monitored, and specify a key or value pair of instance to help organize and search. Provide a name for the key pair. Then on the left side panel, choose security groups under network and security. Select the desired security group and click on the inbound tab to enter the desired rule. To allocate an elastic IP address, use the elastic IPs tab of the network and security left side panels. On Linux or Unix systems, the port number below 1024 can only be assigned by the root. The plain ASCII file called services maps friendly textual names for internet services. Four types of example. NetStat 15 by TCP, FTP 21 UDP, SSH 22 TCP, Telnet 23 TCP, HTTP 80. Right. How to launch an EC2 Linux instance and connect to it. Okay, this section gives a step-by-step process to launch EC2 Linux instance from a Linux platform. It'll launch an instance. Okay, from the AWS Management Console, select EC2, and once signed in, go to Launch Instance tab. To determine the processor architecture, when you want to match the instance with the hardware, enter the command uname -m and choose an appropriate Amazon Linux AMI by pressing select button. Okay, choose instance details to control the number, size, and other settings for instances also. To learn how the system works, press continue to select the default settings also. Okay, define the instances security as we know that one. In the create key pair page, enter a name for the pair and then press create and download key pair. Right, the key pair file downloaded in the previous step is a .pem file and it must be hidden to prevent unauthorized access. If the file is in the directory awcdar slash data.pem, enter the command cd awcdar chmod 400 data.pem. Configure the firewall. Okay, go to the page configure firewall, select the option create a new security group and provide a group name. Normally we use SSH to communicate with the instance. The default port for communication is port 8080 and we can change the port and other rules by creating a new rule here. Press continue and examine the review page which gives a summary of the instance. Okay, press launch and examine the confirmation page, then press close to the end the examination of the confirmation also. Press the instances tab to the navigation panel to view the instance. Okay, look for your public DNS name because by default some details in the instances are hidden. Click on show or hide tab on top of the console and select public DNS also. Okay, record the public DNS as public DNS name. It is needed to connect to the instances from the Linux terminal. They use the elastic IP panel to assign an elastic IP address if a permanent IP address is required. They connect to the instance using SSH and TCP transport protocol. Add a rule to the IP tables to allow SSH traffic using the TCP protocol. Without this step, either an access denied or permission denied or error message appears when you are trying to connect to the instance. Sudo IP tables minus A, IP tables minus P minus TCP minus D port SSH minus J accept. Enter the Linux command SSH minus I abc.pem ec2 minus user. Add public DNS name. Okay. An icon of the Amazon Linux AMI will be displayed. Okay. Gain root access to the instance. Okay. By default, the user does not have root access to the instance. Thus, the user cannot install any software. Once connected to the EC2 instance, use the following command to gain root privileges. Sudo space minus I, then you will get the root privileges. Then use yum install commands to install software. Example GCC to compile C programs on the cloud also. Okay, run the services using service name. If the instance runs under Linux or Unix, the service is terminated when the SSH connection is closed. To avoid the early termination, use the command no-hub service name. To run the service in the background and redirect to std-out and std-error to files p.out and p.error respectively. To execute the command no-hub service name greater than p.out to greater than p.error and right. How to use S3 in Java? The Java API for Amazon Web Services is provided by the AWS SDK. Create an S3 client. S3 access is handled by the class Amazon S3 client instantiated with the account credentials of the AWS user. The access and the secret keys can be found on the user's AWS account homepage as mentioned in last section's buckets. An S3 bucket is analogous to a file folder or directory and it is used to store S3 objects. Bucket names must be globally unique, hence it is advisable to check first to see whether the name exists. S3 dot does bucket exist? Okay, this function returns true if the name exists and false otherwise. Buckets can be created and deleted either directly from the AWS management console or programmatically as follows. S3 dot create bucket of bucket name, S3 dot delete bucket of bucket name, S3 objects. An S3 object stores the actual data and it is indexed by the key string. A single key points to only one S3 object in one bucket. Key names do not have to be globally unique, but if an existing key is assigned to a new object, the original object indexed by that key is lost. To upload an object in a bucket, we can use the AWS Management Console or programmatically. A file local underscore file underscore name can be uploaded from the local machine to the bucket underscore name and the key key using file f equal to new file local file name s3 dot put object of bucket name key comma f. A versioning feature for the object in S3 was made available recently. It allows us to preserve, retrieve, and restore every version of S3 object to avoid problems in uploading large files. Example: dropped connections use the initiate multi-part upload with an API described at the Amazon S3 client. To access this object with key from the bucket name use S3 object myfile equal S3 dot get object of bucket underscore name of the key. To read this file, you must use the S3 object's input stream. Input stream in equal to myfile dot get object connect function. Right. The input stream can be accessed using scanner, buffer reader, or any other supported methods also. Amazon recommends closing the stream as early as possible since the content is not buffered and it is streamed directly from the S3. An open input stream means an open connection to S3. For example, the following code will read an entire object and put the contents to the screen only. Amazon S3 client S3 equal new S3 client only. Right. Batch upload or download. Batch upload requires repeat calls of s3.put object while iterating over local files to view the keys of all objects in a specific bucket. Use object listing s3 equal list objects bucket underscore name. Object listing supports several useful methods including get object summarizes. S3 object summary encapsulates some of the S3 object properties. ఓకే. రైట్. ఇది చూడండి మీరు ఫర్ ఎగ్జాంపుల్ ద ఫాలోయింగ్ కోడ్ విల్ క్రియేట్ ఎ లిస్ట్ ఆఫ్ కీస్ ఇన్ పర్టిక్యులర్ బకెట్ అండ్ ఆల్ ఆఫ్ ద కీస్ అవైలబుల్ ఇన్ స్ట్రింగ్ ఫ్రమ్ ద లిస్ట్ ఆఫ్ కీస్ ఆల్ కీస్. ఓకే. ఈ ఆల్ కీస్ నుంచి మనం తీసుకుంటా ఉంటాము అనేది చెప్పారు. హౌ టు మేనేజ్ ఎస్‌క్యూఎల్ సర్వీసెస్ ఇన్ సి హ్యాష్ అండి. ఐ థింక్ దిస్ ఈస్ నాట్ డిఫికల్ట్. ఐ ఫీల్ దట్ ఇట్ ఈస్ డిఫికల్ట్. Okay, authenticate as SQL connection. Okay, name value collection app configuration manager dot a app settings. Amazon SQS Amazon client client factory settings. Create Amazon SQL SQC client. Okay, create a queue. Next create queuing చేయండి. Next ఎవరిని చేయండి queue actions in SQS simple queue services. Receive a message and delete a message and delete a queue also here. How to install the simple notification service on Ubuntu also. In Ubuntu is an open source operating system for personal computer based on the Debian Linux distributions. The desktop version of the Ubuntu supports the Intel 8632-bit and 64-bit architecture. The simple notification service is a web service for monitoring applications, workflow systems, time-sensitive information updates, mobile applications, and other event-driven applications that require a simple and efficient mechanism for message delivery. SNS pushes messages to clients rather than requiring a user to periodically poll a mailbox to other site for messages also. Right. SNS is based on the publish subscribe paradigm. It allows a user to define the topics, the transport protocol, simple mail protocol, hypertext transfer protocol, SMS protocol, POP protocols. ఇన్ని ప్రోటోకాల్స్ యూజ్ చేసి మనం ఏదో ఒక యాక్షన్ తీసుకోవాలి. యాడ్ ఆర్ రిమూవ్ పర్మిషన్స్, కన్ఫర్మేషన్, సబ్స్క్రిప్షన్, క్రియేట్ ఆర్ డిలీట్ టాపిక్, గెట్ ఆర్ సెట్ టాపిక్ అట్రిబ్యూట్స్, లిస్ట్ డిస్ట్రిబ్యూషన్ టాపిక్స్, సబ్స్క్రైబ్ బై టాపిక్, publish or subscribe unsubscribe tops, install Java, the root discovery, execute the commands, then Java settings are here like this. Download the SNS client, unzip the file and change the permissions also here. Okay, SNS only. How to create EC2 placement group and use MPI. Okay, చూడండి ఇక్కడ. An EC2 placement group is a logical grouping of instances that allows the creation of a virtual cluster. When several instances are launched as an EC2 placement group, the virtual cluster has a high bandwidth interconnect system suitable for network bound applications. The cluster computing instances require a hardware virtual mechanism, ECB based mechanism, machine images, whereas other instances use a para-virtual mechanism image. Such clusters are particularly useful for high performance computing when most applications are communication intensive. Once a placement group is created, message passing interface can be used for communication among the instances in the placement group. Message passing interface is a de facto standard for parallel application using message passing designed to ensure high performance, scalability, and portability. It is a language independent message passing application programmer interface together with the protocol at the semantic specification for how its features must be behave in any implementation. Sports is here. The following C code illustrates the startup of MPI communication for a process group. MPIs and like this only. Okay, there is a program is there. You need to follow this program అండి. ఇదేనండి చేయాల్సింది మీరు. How to install Hadoop Eclipse on Windows system. This is the main problem. Hadoop Eclipse on a Windows system. Right. The software packages used Eclipse is a software development environment that consists of an integrated development environment and an extensible plugin systems. It is written mostly in Java, can be used to develop applications Java and means by various plugins in C, C++, Perl, PHP, Python, R, Ruby, and several other languages. The IDE is often called a Eclipse, CDT or for C, C++. Eclipse, JDT for Java, and Eclipse PDT for PHP. Apache Hadoop is a software frame that supports data-intensive distributed applications under a free license. Hadoop was inspired by Google MapReduce. Okay, using Hadoop is there. Okay, Cygwin is a unique Unix Linux environment of Microsoft Windows only. This is the POSIX API functionality and an extensive collection of software tools and applications that provide Unix look and feel only. Prerequisites for this one Java 16. Okay, SSH installer Cygen. Okay, configurations answers yes. Okay, Cygen open -1 ఇవన్నీ. Okay, unpack Hadoop also ఇదంతా. Format of name node cd hadoop mkdir logs bin hadoop name node format cloud based simulation of a distributed trust algorithm. The mobile wireless applications are likely to benefit from cloud computing. Okay, to the convenience of data access from any site connected to the internet. Yeah, the data transfer rates will wireless network and increasing. The time to transfer data and from a cloud is no longer limiting factor also. Yeah, right. Mobile devices have limited resources, whereas new generation of smartphones and tablets computers are likely to use multi-core processors and have a fair amount of memory. Power consumption is and will continue be a major concern in the near future. There is seem to be reasonable to delegate compute and data incentive task extremely entity is example as a cloud. The first application we discuss is a cloud-based simulation for trust evaluation in a cognitive radio network. The available communication spectrum is a precious commodity, and the objective of a CRN is to use the communication bandwidth effectively while attempting to avoid interface with licensed users. Two main functions necessary for the operations of CRN are sensing and spectrum management. In the form of detects your unused spectrum and the later decides the optimal use of the available spectrum. Spectrum sensing the CRNs based on information provided by the nodes of the network. The nodes of compete for the free channel and some may supply the delivery CNNs. Cognitive network models, cognitive radio networks. Research over the last decade reveals a significant temporal and spatial un- uh, underutilization of the allocated spectrum. Thus there is a motive to opportunity harness the vacancy of spectrum at the given time and place. The original goal of cognitive radio first to proposed at Bell Labs was to develop a software-based radio platform that allows a recognized reconfigurable wireless transceiver to automatically adapt uh, communication parameters to network availability and to user demand. Today, the focus of cognitive radio and spectrum sensing. We recognize two types of digital commands: CRN, primary and secondary CRN, primary secondary. Primary nodes device have exclusive rights to specific regions of the spectrum. Secondary nodes device enjoy only dynamic spectrum access are able to channel provide that primary license to use that of the channel that communicating. Once a primary starts its transmission, the secondary using the channel is required to relinquish and identify another free channel to continue its operation. This mode of the operation is called the overlay mode. ఇంకా కాగ్నేటివ్ radio network అండి. Research over the last decade reveals a significant temporal and spatial underutilization of the allocated spectrum. రీసెర్చర్ 10 సంవత్సరాల నుంచి ఏం చేస్తున్నారంటే టెంపోరల్ అండ్ స్పాషియల్ టెంపోరల్ అండ్ స్పేషియల్ అండర్ యూటిలైజేషన్ ఆఫ్ ద అండర్ యూటిలైజేషన్ ఆఫ్ ద allocated spectrum. Hmm? Thus, there is a motivation. Okay, sir, there is a motivation to opportunistically harness the vacancies of spectrum at a given time and place also. The original goal of cognitive radio, first proposed at Bell Labs in 46 by 47, was to develop a software-based radio platform that allows a reconfigurable wireless transceivers to automatically adapt its communication parameters to network availability and to user demands. Okay, today the focus of cognitive radio is on spectrum sensing only. We recognize two types of devices connected to a CRN: primary and secondary. Primary nodes or devices have exclusive right to specific regions of the spectrum. Secondary nodes devices enjoy dynamic spectrum access and are able to use a channel, provided that the primary license to use that channel is not communicating once a primary starts its transmission. The secondary using the channel requires to relinquish it and identify about free channel to continue its operation. This mode of operation is called an overlay mode అంటాం. ఈ మోడ్ని ఏమంటాడు ఓవర్లే మోడ్ అని చెప్తాం. త్రీ ఛానల్స్ వస్తే జస్ట్ ఓవర్లే అవుతూ ఉంటాయి జనరల్గా. Right, CRNs are often based on a cooperative spectrum sensitive strategy. Right, in this mode of operation, each node determines the occupancy of the spectrum based on its own measurements combined with information from its neighbors and then shares its own spectrum occupancy assessment with its neighbors. Okay, information sharing is necessary because a node alone cannot determine the true spectrum occupancy. Indeed, a secondary node has a limited transmission and reception range node mobility combined with a typical wireless channel impairments such as multipath fading, shadowing, and noise add to the difficulty of gathering accurate information by a single node only. Yes, see here. See. Right. CRNs are often based on a cooperative spectrum sensing strategy. In this mode of operation, each node determines the occupancy of the spectrum based on its own measurements, combined with information from its neighbors. Right. Information sharing is necessary because a node alone cannot determine the true spectrum occupancy. Indeed, a secondary node has a limited transmission and reception range. Node mobility combined with typical wireless channel impairments such as multipath fading, shadowing, and noise, and add to the difficulty of gathering accurate information by a single node. Okay, individual nodes of a centralized or infrastructure-based CRN send the results of their measurements regarding spectrum occupancy to a central entity, whether a base station as an access point or a cluster head. This entity uses a set of fusion rules to generate the spectrum occupancy report and then distribute it to the nodes in jurisdiction. The area covered by such networks is usually small single global spectrum decisions are affected by the global geometrically. If there is another mode of operation on the idea that the secondary node operates much lower power level than primary one. In this case, secondary can share the channel with as primary as much, as long as the transmission power is below threshold mu. That has to be determined periodically in this scenario. The receivers that want to listen the primary are able to filter out the noise caused by the transmission initiated in the ratio of S by N is large enough. Right. We are only concerned with the overlay mode whereby a secondary node maintains to an occupancy report which gives a snapshot of the current status of the channels in the region on the spectrum is able to access or out the accuracy occupancy report is a list of all channels and their state is example 0 if the channel is free for the and 1 for the primary active channel. Secondary nodes continuously sense the channels available to them to gather accurate information about the available channels. Right. The secondary nodes of an individual ad hoc CRN compete for the free channels and the information one node may provide to its neighbors could be deliberately distorted. Malicious nodes will send false information to the fusion center in a centralized CRM. Malicious nodes could attempt to deny the services or to cause other secondary nodes to violate spectrum allocation rules. To deny the service, a node will report that free channels are used by the primary. To entice the neighbors to commit Federal Communication Commission violations. The occupancy report will show the channels used by the primary are free. This strategy is called a secondary spectrum data falsification by Janto attack. Okay, there are trustees there. Coming to the trust only. The actual meaning of trust is to domain that context specific. Consider, for example, networking at the MAC layer, the multi-access protocol assume that all senders follow the channel's access policy. Example, carrier sends multiple access with the collision detection. A sender senses the channel and then attempts to the transmit if the no one is else does not. Right. Right. In the context of cognitive radio, trust is based on the quality of information regarding the channel activity provided by a node. The status of individual channels can be accessed by each node based on the results of its own measurements, combined with the information provided by its neighbors, as in the case of several algorithms discussed in the literature survey also. Right. The algorithm computes the trust of node 1 less than or equal I less than equal to n. In each node in its vicinity, J belongs to Vi and requires several preliminary steps. The basic steps executed by node I at a time T are determine node I's version of the occupancy report for each one of the K channels. Si of T equal to Si I of 1 comma T, Si comma 2 of T, so on Si K of T. In this step, node I measures the power received on each of the K channels. Okay, determine the set Vi of T of the nodes in the vicinity of node I. Node I broadcasts a message and individual nodes in its vicinity respond with their node ID. Determine the distance to each node j belongs to A of t using the algorithm described in this section. Yeah. Uh, Infer the power as measured by each node j belongs to A of t. On each channel k belongs to k. మెల్లగా use the location and power information తడిసిపోతే బయటికి తడిసిపోతే బయట ఆంటీ ఇక్కడ బయలుదేరుతున్నారు ఇక్కడ ఆంటీ ఇక్కడ ఉండరు ఇక్కడ పెట్టేసి వెళ్ళు తడిసిపోతాయి. Use the location and power information determined the previous two steps to interfere the status of each channel. Okay, infer S I K J of T, 1 less than K less than K, J belongs to A of T. A secondary node J should have determined 0 if the channel is free for use. 1 if the primary node is active, and X if it cannot be determined. The infer Sij of t equal to 0 if the secondary node j decides that channel k is free, equal to 1 if secondary node j decides that channel k is used by the primary, equal to x if no inference can be made. Sixth one, receive the information provided by neighbor j belongs to vi of t s recursive of ikj of t. So by using these formulas, we can calculate the number of mismatches between the two vectors of xij and no inference could be made it. So use the quantities alpha I j of t, comma beta I j of t and xi j of t to access the trust in node j. For example, compute the trust of node I and node j at a time t as okay, it of equal 1 plus xi j of t. Alpha I j of t by alpha I j of t plus beta I j of t. A simulation of the distributed trust algorithm here. The cloud application is a simulation of a CRN to access the effectiveness of a particular trust assessment algorithm. Right. Multiple instances of the algorithm run concurrently on an AWS cloud. The area where the secondary nodes are located is partitioned into several overlapping subareas. Okay, the secondary nodes are identified by an instance ID, okay, IID as well as the global ID GID. Okay, the simulation assumes that the primary nodes cover the entire area, thus their positional is immaterial. Right. The simulation involves a controller and several cloud instances. In its initial implementation, the controller runs on a local system under Linux Ubuntu. The controller supplies the data, the trust program, and the script the cloud instances. The cloud instances run under the base 32-bit Linux image on AWS, the so-called T1.micro. The instances run the actual trust program and compute the instances trust inferred by a neighbor. The results are then proposed by an AWK script to compute the average trust associated with a node as seen by all its neighbors. On the next version of the application, the data is stored on the cloud using the S3 service. And the controller also runs the cloud and the runs the in the simulation discussed here, the nodes with GID equal to 1, 3, 6, 8, 12, 16, 17, 28, 29, 32, 35, like these numbers are there, were programmed to be dishonest. The results show that the nodes programmed to act maliciously have a trust value lower than that of the host nodes, honest nodes. Their trust value is always lower than zero point 0.6 and in many instances lower than zero point 0.5. We also observe that the node density affects the accuracy of the algorithm. The algorithm predicts more accurately the trust in densely populated areas, as expected nodes with no neighbors are unable to compute the trust. A trust management service. A trust management service. The cloud service is here also. is an alternative to the distributed trust management scheme analyzed. Mobile devices are ubiquitous nowadays and their use will continue to increase. Clouds are emerging as the computing and storage engines of the future for a wide range of applications. There is a symbiotic relationship between the two. Mobile devices can consume as well as produce very large amounts of data, whereas computer clouds have the capacity to store the deliver such data to the user of a mobile device. To exploit the potential of this symbiotic relationship, we propose a new cloud service for the management of wireless networks. Mobile devices have limited resources. New generations of smartphones and tablet computers are likely to use multi-core processors and have a fair amount of memory, but power consumption is still and will continue to be major concern. Thus, it seems reasonable to delegate an data-intensive task to the cloud. The motivation for this application is to reduce the power consumption of the mobile devices. Yet transferring computations related to CRN management to a cloud support the development of new possibly more accurate resource management algorithm. For example, algorithms to discover communication channels currently in use by a primary transmitter could be based on past history, but are not feasible when the trust is computed by the mobile device. Such algorithms require massive amounts of data, can also identify malicious nodes with high probability. Mobile devices such as smartphones and tablets are able to communicate using networks. One, a cellular wireless network, and second one, a Wi-Fi network. The service we propose assumes that a mobile device uses a cellular wireless network to access the cloud, whereas the communication over the Wi-Fi channels is based on the cognitive radio. The amount of data transferred using the cellular network is limited by the subscriber's data plan, but no such limitations exist for the Wi-Fi network. The cloud service discussed here will allow mobile devices to use the Wi-Fi communication channels in a cognitive radio network environment and will reduce the operating cost of every end user. Uh, Although the focus of our discussion in the management of CRM, the cloud service we propose can be used for tasks other than bandwidth management. Model assumptions. The cognitive radio literature typically analyzes networks with relatively small number of nodes and active in limited geographic area. Thus, all nodes in the network sense the same information on the channel occupancy. Channel impairments such as signal fading, noise, and so on causes errors and lead to trustworthy nodes to report false information. We consider networks with a much larger number of nodes distributed over a large geographic area. As the signal strength decays with the distance, we consider several rings around primary tower. We assume a generic fading model given by the following expressions. In our discussions, we assume that there are k channels labeled 1, 2, and so on k, and a primary transmitter p power k transmits on a channel k. The algorithm is based on several assumptions regarding the secondary nodes, the behavior of malicious nodes, and the geometry of the system. First, we assume that the secondary nodes are mobile devices. Some are slow moving, other are fast moving. Cannot report their position because they are not equipped with a global positioning systems. The clocks of the mobile devices are not synchronized. The transmission reception range of a mobile device can be different. The transmission range depends on the residual power of each mobile devices also. We assume that the malicious nodes in the network are a minority and their behavior is captured by the following assumptions. The misbehaving nodes are malicious rather than selfish. Their only objective is to hinder the activity of other nodes whenever possible. A behavior distinct from the nodes of them gain some advantage. The malicious nodes are uniformly distributed in the area we investigate. The malicious nodes do not collaborate to their attack strategies. The malicious node change the intensity of their Bigenetic attack in successive time slots. Similar patterns of malicious behavior are easy to detect, and an intelligent attacker is to motivated to avoid detections. The geometry of the system is captured by the figure. We distinguish primary and secondary nodes and cell towers used by the secondary nodes to communicate the services running on the cloud. Okay, right. Right. A cloud service for adaptive data streaming. Service for adaptive data streaming. A data streaming is the name given to the transfer of data at a high rate with real-time constraints. A data streaming and data transferring of data with high rate. A multimedia application such as music and video streaming, high definition television, scientific applications that process a continuous stream of data collected by sensors. The continuous backup copying the store to a storage medium of the data flow within a computer and many other applications require the transfer of real time data at a high rate only. For example, to support real-time human perception of the data, multimedia applications have to make sure that enough data is being continuously received without any noticeable time lag. So we are concerned with the case when data streaming involves a multimedia application connected to a service running on a computer cloud. The Steam cloud originate from the cloud, as is the case of the iCloud service provided by the Apple, or could be directed toward the cloud, okay, as in the case of the real-time data collection analysis team. Data streaming involves three entities: the sender, a communication network, and a receiver. The resources necessary to guarantee the timing constraints include CPU cycles and the buffer space at the sender and the receiver, as well as network bandwidth. Okay, adaptive data streaming determines the data rate based on the available resources. Lower data rates imply lower quality, but they reduce the demands for the system resources. Right. Adaptive data streaming is possible only if the application permits trade-offs between quantity and quality also. Such trade-offs are feasible for audio and video streaming, which allow lossy compression but are not acceptable for many applications that process a continuous stream of data collected by sensors. Data streaming requires accurate information about all resources involved, and this implies that the network bandwidth has to be constantly monitored. At the same time, the scheduling algorithm should be coordinated with memory management to guarantee the timing constraints also. Right. Adaptive data streaming poses additional constraints because the data flow dynamic. Indeed, once we detect that the network cannot accommodate the data rate required by an audio or video stream, we have to reduce the data rate. Thus, to convert a lower quality audio or video. Data conversion can be done on the fly, and in this case, the data flow on the cloud has to be changed. Okay, accommodating dynamic data flows within timing constraints it is non-trivial. Only about 18% of the top 100 global video websites use adaptive bitrate technology streaming. Right, this application stores the music files in S3 bucket. The audio services runs on the EC2 platform also. In EC2, each virtual machine functions as an virtual private server and is called an instance. An instance specifies the maximum amount of resource available to an application, the interface for that instance, and the cost per hour also. EC2 allows the import of virtual machine images from the user environment to an instance through a facility called VM import. It also distributes automatically the incoming application traffic among multiple instances using the elastic load balancing facility. EC2 associates an elastic IP address with an account. This mechanism allows a user to mask the failure of an instance and remap a public IP address to any instance of an account without the need to interact with the software support team also. Adaptive audio streaming involves a multi-objective optimization problem. We want to convert the highest quality audio file to file stored on a cloud to a resolution corresponding to the rate that can be sustained by available bandwidth. At the same time, we want to minimize the cost on the cloud side and minimize the buffer requirements for the mobile devices to accommodate the transmission jitter. Finally, we want to reduce a minimum the startup time for the content delivery also. A first design decision is whether the data streaming should only begin after the conversion from the WAV to MP3 format has been completed, or it should be processed concurrently with conversion. In other words, start as soon as several MP3 frames have been generated. Another question is whether the converted music file should be saved for later or discarded. To answer these questions, we experimented the conversion from the highest quality audio files, which require a 320 kbps data rate, a low quality files corresponding to 190 to 120, 64, and finally 16 kbps. If the conversion time is small and constant, there is no justification for pipelining data conversion and streaming, a strategy that complicates the processing flow on the cloud. It makes sense to catch the converted copy for a limited period of time with the hope that it will be reused in the future also. Another design decision is how the two services should interact to optimize performance. Two alternatives come in mind. First one, the audio service running on the EC2 platform requests the data file from the S3, converts it, and eventually sends it back. The solution involves multiple delays and it is far from the optimal. Mount the S3 bucket and EC2 drive. This solution reduces considerably the startup time for audio streaming. Right. The conversion from a high quality audio file to a lower quality, thus a lower bitrate file is performed using the LAME library only. The conversion time depends on the desired bitrate and the size of the original file also. Right. The sizes of the input files are also shown here. The platforms used for the conversion are EC2 T1.micro server for the measurement reported is here. The result of our measurements when the instance is the T1 micro server exhibit a wide range of conversion time 13 to 80 seconds. For the large audio file of about 6.7 MB when we convert from the 320 to 190 kbps. A wide range 30 to 64 seconds is also observed for an audio file of about 4.3 MB. When we convert from 320 to 128 kbps, okay, for poor quality audio, the file size is considerably smaller, about 0.56 MB, and the conversion time is constant and small 4 seconds. Okay, the figure shows that the average conversion time for the experimental summarized tables is there. Here the figure is there. You see to T1 dot micro platform only. Next one is the cloud-based optimal FPGA synthesis and cloud-based optimal FPGA synthesis. Alright, here we discussed another class of application that cloud benefit from cloud computing. What are the benefits from the cloud computing? Okay, we know that cloud applications in computational science and engineering also. The benchmarks also we discussed about this. The performance of several codes running on a cloud with runs on a supercomputers also. అంటే మన క్లౌడ్ కంప్యూటర్ సూపర్ కంప్యూటర్స్లో మన క్లౌడ్ కంప్యూటింగ్ సూపర్ కంప్యూటర్స్ ఎలా వర్క్ అవుతుంది అనేది చూడాలి. As expected, the results showed that a cloud is not an optimal environment for applications exhibit fine or medium grain parallelism. Indeed, the communication latency is considerably larger on a cloud than a supercomputer with more expensive custom interconnect. Right. This means that we have to identify cloud applications to do involve extensive communications or applications. అంటే మనకి క్లౌడ్ కంప్యూటింగ్ సూపర్ కంప్యూటర్స్ ఎలా వర్క్ అవుతుంది ఏంటి అనేది చూపించారు ఇక్కడ. చూడండి నెక్స్ట్. A cloud is an ideal running environment for scientific applications that involves model development. In this case, multiple cloud instances could concurrently run slightly different models of the system also. అంటే మనకి క్లౌడ్ కంప్యూటింగ్లో మనకి కాంకరెంట్గా ప్యారలల్గా ఒకేసారి రన్ చేయడానికి కూడా ఉపయోగపడుతుంది. When the model is described by a set of parameters, the application can be based on the SMPD paradigm combined with an analysis phase when the results from the multiple instances are ranked based on a well-defined metric. Right. In this case, there is no communication during the first phase of the application. When partial results are produced and then written to the storage server also. The individual instances signal the completion and a new instance to carry out the analysis and display the results is started. A similar strategy can be used by engineering applications of mechanical, civil, electrical, electronics, or any other system design area. In this case, the multiple instances run concurrent design for different sets of parameters of the system. A cloud application for optimal design of field programmable gate arrays is discussed here. As the name suggests that the FPGA is an integrated circuit designed to the configured, adapted, or programmed in the field of field to perform a well-defined function. Such a circuit consists of logic blocks and interconnects that the that can be programmed to carry out logic or combinational functions also. Right. The first commercial viable FPGA, the XC20 produced in 1985 by Xilinx. అంటే Xilinx వాళ్ళు ఫస్ట్ ఇది యూజ్ చేశారండి. టుడే FPGAs are used in many areas, including digital signal processing also, CRNs, aerospace, medical imaging, computer vision, speech recognition, cryptography, and computer hardware emulation. FPGAs are less energy efficient and slower than application specific integrated circuits. The widespread use of FPGAs is due to their flexibility and the ability to reprogramming them. This is the circuit here. చూడండి the structure of FPGA with 30 pin PO2 P29. 9 logic blocks are there and 4 switch blocks. ఈ 4 స్విచ్ బ్లాక్స్ 9 లాజిక్ బ్లాక్స్ ఉన్నాయి. 4 స్విచ్ బ్లాక్స్ మధ్య 9 లాజిక్ బ్లాక్స్ ఉన్నాయి. దీనికి పిన్స్ P0 నుంచి P29 వరకు ఉన్నాయి. ఈ స్విచెస్, ఇది స్విచ్ బ్లాక్. ఇక్కడ మనకి స్విచ్ బ్లాక్స్ అనేవి ఉన్నాయి. 4 స్విచ్ బ్లాక్స్ ఆర్ అవైలబుల్. Okay, in this there are 9 logic blocks are available. అలాగే మనకి పిన్స్ కూడా ఉంది ఇటు ఇటు. ఓకే, 30 పిన్స్, మొత్తం 30 పిన్స్ ఉన్నాయి అన్నారు ఇక్కడ. ఓకే, రైట్ హియర్, సీ హియర్. Hardware description language HDL such as VHDLs, Verilog are used to program FPGAs. దీన్ని ప్రోగ్రామింగ్ చేయడం కోసం హార్డ్వేర్ డిస్క్రిప్షన్ లాంగ్వేజెస్లో VHDL అనేది వెరీలాగ్ అనేది ఇంపార్టెంట్. HDLs are used to specify a register transfer level description of the circuit. Multiple stages are used to synthesize FPGAs. A cloud-based system was designed to optimize the routing and placement of components. The basic structure of the tool is here shown in 11. The basic tools. Now, the architecture of a cloud-based optimized routing placement. ఇది క్లౌడ్ క్లయింట్, ఇది EC2 క్లౌడ్ ఇన్స్టాన్సెస్. ఇవన్నీ ఇక్కడ ఫస్ట్ ఏంటంటే బూట్ ఎన్ ఇన్స్టాన్సెస్ ఆన్ EC2 అంటాం. సెండ్ యూజర్ డేటా, ప్రాజెక్ట్ నేమ్ అండ్ గ్లోబల్ QURL. నెక్స్ట్ మనకి డేటాను యూజర్ డేటాను పంపిస్తుంది క్లౌడ్కి. రైట్. స్టోర్ వర్క్ ప్యాకేజెస్. వర్క్ ప్యాకేజ్ స్టోర్ చేయడం కోసం. క్లౌడ్ నుంచి మనకి ఫుల్ వర్క్ ప్యాకేజెస్ మనకి బ్యాక్ వస్తాయి అన్నమాట. నెక్స్ట్ వెయిట్ అంటిల్ ద ఇన్స్టాన్స్ హ్యావ్ ఫినిష్డ్. మనకి ఇక్కడ సిగ్నల్ కంప్లీషన్ అవుతుంది, అప్పుడు వెయిట్ చేస్తున్నాయి, క్యూలోకి వచ్చేస్తుంది దీంట్లో. నెక్స్ట్ ఏంటంటే స్టోర్ రిజల్ట్స్, రిక్వెస్ట్ రిజల్ట్స్ అండ్ అనలైజ్, నెక్స్ట్ క్లీనింగ్ అప్ అనమాట. ఇవన్నీ ఉన్నాయి అని చెప్తున్నారు. ఇంకా bigger. The system used the plan ahead tool from the Xilinx to place system components and root chips on the FPGA's logic fabric. The computations involved are fairly complex and take a considerable amount of time. For example, a fairly simple system consisting of a software core processor, a block random access memory, and a couple of peripherals can take up to 40 minutes to synthesize on a powerful workstation. Running and design options in parallel on a cloud speeds up optimization process by a factor close to n only. Okay, there are some of the problems are there here. Okay, establish an AWS account. Use the AWS management console. These are the exercise problems are there here. Okay, we need to finish exercise problems also. Okay, this is about the cloud computing last unit అండి. ఏంటి అంటే మనకి ప్లాట్ఫామ్ యాజ్ ఎ సర్వీసు, ఇన్ఫ్రాస్ట్రక్చర్ యాజ్ ఎ సర్వీసు, సాఫ్ట్వేర్ యాజ్ ఎ సర్వీసెస్, ఈ సర్వీసెస్ను ప్రొవైడ్ చేస్తే ఒక క్లౌడ్ ప్రొవైడ్ చేస్తుంది. ఓకే, బేస్డ్ ఆన్ ద సర్వీసెస్ సమ్ ఆఫ్ ది ఫైట్ చేసుకోకుండా ఒక్కొక్కళ్ళు తీసుకున్నారండి. ఇది క్లౌడ్ అప్లికేషన్ డెవలప్మెంట్, క్లౌడ్ అప్లికేషన్ డెవలప్మెంట్.